guys, welcome to section 3 videos, two-dimensional kinematics. This is example 1 of many examples on vectors, and as the examples get higher, the problems will get more difficult. So let's hop to it. A car is driven 216 kilometers east and then 86 kilometers southeast. What is the displacement of the car from the point of origin? So the magnitude and the direction. Draw a diagram. So the first thing I've gone ahead and done here is drawn a Cartesian plane. Okay, we're dealing with northeast, southwest. So you do your Cartesian plane, northeast. Obviously, you can label them all if you'd like. Okay, so the first motion is 216 kilometers east. So I've represented that as D1. Okay, so you've got a long vector going in just the D1 direction. Then we have 86 kilometers southeast. Now, something you have to note, also for future questions, whenever you see two directions here, like southeast, northwest, northeast, southwest, whatever it is, because there's two directions there, the vector is equally split between the two. Okay, if it doesn't tell you an angle, you assume it's 45 degrees. Okay, so therefore I've drawn a shorter vector here because it's 86 compared to 216, and pardon me, and it's at a 45 degree angle. Okay, so I'm going to go ahead and label that. That's 45 degrees. And what we've been asked to find is the displacement of the car. So the overall displacement after D1 and D2. Now in vector language, we call that the resultant. Okay, so the resultant is for the ending of different motions. Okay, and we're going to represent that as dr, resultant displacement. Now just a quick review on vectors really fast here. Remember, a vector is a quantity that has both magnitude and direction, and because it has a direction, you have to put that little arrow on top, okay, to show that it is indeed a vector. Okay, a vector would be something like velocity, okay, something that has magnitude and direction, 46 kilometers an hour east, okay, whereas speed is a scalar quantity that only has magnitude, 46 kilometers an hour, okay. Other things that are qualifying as scalars would be age, okay, because 14 years, you can't say I'm 14 years north, that doesn't make any sense. Your mass, okay, 60 kilograms, you're not 60 kilograms northeast. Again, it doesn't make sense. So certain things are, or even time is a scalar. But displacement, velocity, magnetic field, these things are vectors, okay, magnitude and direction. Nonetheless, we're dealing with displacement here, so let's hop right into it. So the way we do this is the resultant displacement is the sum of the two displacements d1 and d2. Now, again, because these are vectors, this doesn't mean that whatever d1 is 216 and d2 86. This does not mean it's 216 plus 86 because it has the vector symbols on top. That means you have to take into account the direction. This means I'm adding the vectors together, not the numbers. So you have to be really careful with that. Whenever you see the symbols on top, don't just add them like they're scalars or add them linearly. We have to add them with the directions, and that involves a bit of geometry, but don't worry, it's actually pretty straightforward. Okay, so something you should notice, D1 is purely in one direction, east, but D2 has components in both the east and the south directions. Okay, so if I go ahead and drop a line to the positive x-axis, I can draw a 90-degree angle there. And I can actually break up D2 into D2 in the south direction and D2 in the east direction. Okay, so that's going to help me a lot when I actually add these together. Okay, so let's work in the east direction first. So we're going to look at the east components. Okay, so in the east direction, D1's already in the east direction, so I'm just going to say, you know what, D1 is D1 east. Okay, again, you stay straight with your subscripts, keep them consistent. It's 216 kilometers. That was easy. It's already in the east direction. Okay, now D2, okay, so D2 east is this little part right here, okay, right there. So you have to look at this as a triangle problem. If you blow this up, you've got a right angle here, you've got a 45-degree angle there, you've got D2 here, which is 86 kilometers, and you're trying to find D2 east. Now, through trigonometry, you should be able to determine that because this is the hypotenuse times the cosine of this angle will give you the adjacent of that angle. Okay, so it's going to be d2 cosine 45 degrees. Okay, d2 is 86 cosine 45 degrees. And 86 cosine 45 is equal to 60.81 kilometers. Okay, and just check that it makes sense. Okay, the hypotenuse should be the longest. The hypotenuse is 86. Your adjacent side is approximately 61. Okay, so we've got our east direction. Now let's add this up. So the total in the east direction, I'm going to call it d subscript e, is equal to d1e plus d2e. And let's add those together. d1e is 216 kilometers. d2e is 60.81 kilometers. And if we add those two together, and we're going to get 276.81 kilometers east. Again, realize that the only reason we were even able to add them like that is because they were both in the same direction. You could not have done that in this step because they're in opposite, different directions. But here they're both going east. Okay, so if you actually write that in there, it's actually better and keep it consistent. So displacement in the east direction, 276.81 kilometers. Okay, so now we have to work with the south direction. So let's do that next. Okay, so now we'll do south components. So based on our earlier picture, you can see that D1 has no south components. It is only D2 that has a south component, and that is right here, D2S. Now based on your knowledge of basic trigonometry, you can know that in order to get this side, which is opposite to this angle, and given the hypotenuse, you need to use sine. Okay, so the hypotenuse times the sine of this angle will give you the opposite side. Okay. So we're going to say D2 south is equal to D2 sine of 45 degrees. Okay, D2 is 86 kilometers, don't forget. And times sine of 45 degrees. So therefore, D2S is equal to 60.81 kilometers. If that number probably looks familiar, that was the same thing we got for D2 East. It doesn't always work out like that. It worked out in this case because sine of 45 and cosine of 45 are the same thing. Okay. All right. So now remember from the previous page we had the total displacement in the east direction, 276.81 kilometers east, and now we just determined the total displacement in the south direction. It is 60.81 kilometers. Okay. Now, in order to add these two together, in fact, these two are going to give us the resultant, right? So we can actually say that the resultant is equal to ds plus de, because we've actually broken it up into the south and the east components. This will actually be really convenient. Okay, so in order to add vectors together like this, we have to add them as they are. Okay, so we have one really long vector going in the east direction. That's our de, which is 276.81. And then we've got a 60.81 going south. Okay, that's ds. 60.81. And so our resultant dr, this is how you add vectors. Whenever you add one to the other, you add it tip to tail. Okay, so the tail of the second one must be touching the tip of the first vector. Okay, so we're adding south to east. So that's why the tail of the south has to touch the tip of the east. And now in order to add them, the resultant always goes from the tail of the first vector to the tip of the second. So in this direction. Okay, so this is D resultant. Make sure you get that direction right. From the tail of the first vector to the tip of the second one. Okay, And the angle you want to do is from your first vector to this hypotenuse, if you will, to the resultant. Okay, that's a right angle there, and we know that for sure because here we're going east, here we're going south. There is a 90-degree angle between south and east. Perfect 90-degree angle. Okay. Okay. So we were asked in the question, if you remember, we're asked to find the displacement of the car from the point of origin, the magnitude, and the direction. So how do we find the magnitude? Well, that's the length of this side. And if you remember from Pythagorean theorem, the length of the hypotenuse, you just use c squared equals a squared plus b squared. Except in this case, instead of c, we have dr. Instead of a, we have de. Instead of b, we have ds. Obviously, a and b can be switched, but this is what we've got, Pythagorean theorem. Okay, so I'm going to write that out here. So we've got dr, the magnitude. That's what these two vertical lines mean. The absolute magnitude of a vector is the scalar quantity. Okay, so dr squared is equal to dE squared magnitude plus ds squared. Okay. So let's solve that. So I'll just drag that over here. dE is 276.81 kilometers squared. Okay, ds is 60.81 kilometers squared. Now remember, whatever number you're getting out of here is dr squared. You then have to square root it, and when you do so, you're going to get dr is equal to approximately 283 kilometers. Okay, now one thing you probably remember from the earlier videos, that annoying thing I know, you have to do Sig Figs, right? So looking at these numbers in the question, we're given 3 Sig Figs here for 216. We're given 2 Sig Figs here for 86. And our answer has to be as certain as the least certain value given in the question. So this actually has to be rounded to 2 Sig Figs. So 283 rounded to 2 Sig Figs is going to give us approximately 280 kilometers. Okay, remember that last 0 is not significant. Okay, so there's our magnitude. We're almost done. We have to find the direction, and that comes into play with theta there. Okay, so all of these questions actually work out pretty much the same in that theta, you're always given these two values and you have to find the hypotenuse. So you're given the opposite and the adjacent of theta, and based on SOHCAHTOA, you would know that you have to use tangent. Okay, so let's go ahead and do that. So tan of theta, and that's what we're looking for here, theta. Okay, so tan of theta is opposite over adjacent, so it's going to be 60.81 over 276.81. When you calculate that out, you're going to get tan theta is equal to 0.21968 approximately. Okay, now in order to get theta by itself, you need to take the inverse tangent of both sides. Remember, tan, you're not multiplying theta by tan. Tan is an operator. So you're applying tan onto theta, so in order to get rid of it, you have to do inverse tangent to both sides. Okay, inverse tangent of tangent gives you 1. Inverse tangent of the right side is going to be inverse tangent of 0.21968. On your calculator, in order to get inverse tangent, all you have to do is, usually you press shift and then the tan button. Okay, regular tan will be regular tan. If you shift tan, you get inverse tan usually. Okay, so when you calculate that out, you get theta is approximately 12.39 degrees, and of course, we got to do our Sig Figs. 2 Sig Figs, so giving us theta is approximately 12 degrees. Okay, now you have the angle, it's great, but you have to be able to express it accurately, okay? So when you add everything together, look at this picture, okay? So this is going east, this is going south. So if this angle here is 12 degrees, essentially what you've done here is you've started off at east and you're going south by 12 degrees. Therefore, your final answer is going to be expressed as this. Therefore, the resultant displacement is 280 kilometers. And then you put your direction in square brackets, 12 degrees south of east. Okay? And that is it. So everything is given according to the correct number of sig figs. 2 sig figs for the angle, 2 sig figs for the resultant displacement, and we have our final diagram. Okay, so that's it for this video, guys. If you enjoyed it, be sure to give that like button a click and subscribe to this channel so that you never miss a video from me. Thank you so much for watching.